In this video and the next few, I would like to begin talking about how changes to the equation of a function affect the graph of that function. We call this transformations of functions. And we want to be very familiar with some of the graphs of common functions presented in an earlier video, such as the square root function, the quadratic function, the absolute value function, and we will begin seeing how to manipulate these equations and corresponding transformations of the graphs. In this video, I'll be discussing vertical and horizontal transformations. So first we have vertical shifts. If we take a function and add or subtract a value at the end of the function to the output, that shifts the graph of the original function up or down that many units. So let's say we want to sketch the graph of f of x equals absolute value of x plus 4. We know that the absolute value function looks like this. This is one of our toolkit functions, and it has points at 0, 0, at 1, 1, and at negative 1, 1, just to name a few. Essentially, as we look at the graph of f of x, every y value on that toolkit function is being shifted upward 4 units. So instead of a point at 0, 0, on the new function, I'm going to have a point at 0, 4. And instead of a point at 1, 1, I'm going to have a point at 1, 5. I'm taking every y value and I'm shifting it upward 4 units by adding 4. So here is the graph of f of x. Another example uses the squared function, x squared minus 3. First, when we consider the toolkit function y equals x squared, we have this graph with points at 0, 0, 1, 1, 2, 4, and so on. For this transformation, as we sketch the graph of g of x, every y value is being moved downward 3 units. So instead of a point at 0, 0, I'm now going to have a point at 0, negative 3. Instead of a point at 1, 1, I'm now going to have a corresponding point at 1, negative 2. And then on the other side, a point at negative 1, negative 2. Instead of a point at 2, 4, I'm going to have a point at 2, 1. This is enough information to sketch the graph of this transformed function. In addition to speaking about vertical shifts, we can also speak about horizontal shifts. So a horizontal shift occurs when we take an x value and we add or subtract a number to the x value inside the function, inside the square root, or inside the squaring or cubing or whatever action is happening in the function. That will shift the graph of the original function left or right c units. And in some ways, the action here is counterintuitive for x. If we add a value to x, the graph is actually moving to the left that number of units. If we subtract a value from x, the graph is moving to the right that number of units. So in our first example, we want to sketch the graph of h of x equals the square root of x minus 3. This 3 is being subtracted from x, and that is actually going to move us to the right 3 units. It's going to shift us in the positive direction. So here is the original toolkit function, y equals square root of x, with some points noted on that function. And as we sketch the new function, h of x, we're going to take every x value and we're going to shift it right 3 units. So instead of a point at 0, 0, I'm now going to have a point at 3, 0. Instead of a point at 1, 1, I'm now going to have a point at 4, 1, and so on. This is enough information to sketch the graph of our transformed function. Finally, let's put both types of transformations together in one example. So we want to sketch the graph of y equals x plus 2 squared minus 1. This minus 1 at the end will move all of our y values down 1 unit. And this plus 2 inside parentheses, inside the squaring action, is going to take all of our x values and move them to the left 2 units. Here is the original toolkit function, y equals x squared, one more time for reference. Has its origin at 0, 0. So we're going to take that and imagine what would it be like if we shifted every point to the left 2 units and down 1 unit. Let's try to track those changes. We could also do this with a table of values. So if I have some x and y values on the original function, for example, we had negative 1, 1, we had 0, 0, and we had 1, 1. Let's see what happens to those on the transformed function. Here we can make a list of x and y values. We're supposed to move each x value to the left 2 units. So I'm going to subtract 2 from each of the x values. We now have the values negative 3, negative 2, and negative 1. And we're supposed to move each y value down 1 unit. So I'm going to subtract 1 from each of the y values. So 0, negative 1, negative 2. These points are now found on the transformed function. And let's graph those points to get a nice sketch. What used to be 0, 0 is now at negative 2, negative 1. And I'm seeing one mistake we made here with this last y value. This should be an output of 0. So we also have the points negative 1, 0, and we have the points negative 3, 0. That's enough to begin sketching a graph of this transformed function. It looks like the graph of x squared, but the points are shifted to the left 2 units and down 1 unit. In the next video, we'll look at some reflections as well to see additional ways that we can transform the graphs and equations of common